Hi, my name is Miss Yuli, and I will explain AMO 2016 Set 1. For number 1, it's quite easy. We just do like basic simple math. We will divide first, and then we multiply, and then do the rest. So for this one, still quite easy. Minus 4 plus 6. So the answer is 17. For number 2, how much greater is the least 3-digit prime? Okay, we have to find what is the largest digit, the smallest, the smallest 3-digit prime is 100. And then we go down because this is not prime number. We're going down, 99 is not, 98 is not, so it's 97. How much greater is the least 3-digit prime? So we go also, so we're going up also, we're going up. So this is going down, we get the greatest 2-digit prime. If we're going up, it's going to be 101. This is digit prime. So the difference is 4. That's the answer. So the least 3-digit prime is 101 and the greatest 2-digit prime is 97. The difference is 4. So number 3, we just expand it. So we can say like this. This is 20 million plus 100. The exponent will be 7. And this going to be 2, right? So the x is 7 and the y is 2. Substitute to this expression. Times this, you get 214. So the answer is 215. Going to number 4, we have to find a pattern. So you can see from number 4, from this number 4, it have pattern that repeated every 6 figure. So that means you have to find how much it keeps cycling and where the last position will be. So 2015 divided by 6, because it keeps repeating every 6 figure. It's 3. Will repeating for 355 cycle, but the remainder is 5. So after it goes cycling for 335 times, it will finally land in the 5th figure. 1, 2, 3, 4, 5. This is the answer. Okay, so the answer is the black triangle. Remember that when you do this kind of contest, you have to raise the time. So try to do every one of each this problem under 1 minute. Okay, number 5. Given the cube shown at the right, an ant travels from vertex A to B. Draw, okay? You just draw. From A, you have 3 possibility of path if you draw like this, right? So the first path is going here. Every single path that you take, it will have 2 possibilities. Because if you take this one, it will go up here or here. So there are 2. If you go back, you also have 2. This one and this path going to B, right? Going to B. So another 2. If you take this path, it also branches to the 2 path. So another 2. So the answer is 6. So as you can see, try to do this under 1 minute. For number 6, find the least value. To find the least value, you have to find this one as small as possible and this one as big as possible. The smallest that can be for 3-digit arithmetic, it will be 124. And this one, you have to try to find the biggest possibility. So it's going to be, I try 97. And remember, it's only 1 to a box. That means you can use only 1 time. So it's going to be like this. We keep trying until we find the biggest possibility of sum. Still keep trying. Okay, so the biggest is 171. 83 plus, 83 plus 124 and minus 171. You count this. So the answer is 36. Go to the next one, number 7. Okay, milk is poured from a full pitcher. Okay, if you find something like this, maybe it's going to be help is if you draw. This is the pitcher and this is the glass. Everything that goes out from the pitcher will go to the glass, right? So it said it's going to be 4/5 full, like this. It will miss 1/5. So 1/5 of the pitcher will go to fill 4/5 milk inside the glass. So we have to find 1/5 out of 40 ounce is 8. So we draw, this is for 4/5, right? So we draw box to help us to think. Okay, this is 5 section. So 4/5 means this much, right? 4/5 contains of 8 ounce. So you get 8 ounce from here to here. That means 1 box. If 4 box is 8, that means 1 box is 2, right? So this box, which is the 1/5, is 2. Because the question is, how many more ounce milk are needed to fill the glass? So you have to find the 1/5, right? So the answer is 2. Number 8. The pyramid shows blah, blah, blah. At least one of the edges on each of the faces is to be colored red. So we just draw. If we color this red, that means the upper triangle doesn't need any more color. We go to the next side. I will draw a line along this. There at the back, that is the line. And then where do we go after this? So this triangle already have one painted red. this triangle already have one edges painted red, and then we go to this one. You can go here, right? Also, you can go here. It's up to you. So if I go in front, here, the front, there. So you don't need to color this part. You don't need to color this part. How about this triangle, the last triangle? The last triangle, you can choose this or this. I choose this one. So by this, all faces already have at least one edge painted red. Okay. So the answer is 4. 1, 2, 3, 4. The answer is 4. Okay, next. For this one, you have to draw. A rock is in the shape of an equilateral triangle. You draw. Okay. Each side of length of 10 feet. So this is 10, this is 10, and this is 10. The rock is entirely composed of 100 equilateral triangle patches with side of length 1 foot. So that means it's going to be like this, and then and so on until the last, right? Until the last. So you can see we're going to have 10 triangles in this side. 10 triangles because this is 10 feet, right? And then the width is 1 foot. So for each side of the triangle, you're going to have 10 triangles. You're going to have 10 here, 10 here, and 10 here. So the total triangle in the perimeter is 30. But for every vertices, you're going to find this 3 triangle will be overlapped, right? So this overlap between this side and this side. This one overlap between this side and this side. This will overlap between this side and this side. So there are 3 overlap. So the answer is 27 triangles. Question number 10. For this, the easiest is to count one by one. Okay, for the number 1, x is half, and then plus minus 1/4. Number 2, number 3, number 4, sorry, this is going to be 2, 4, and it's going to be 1, 4. And number 5, is going to be minus, so it's impossible. So the largest is number 4. The answer is 4. Okay, the first 5 pentagonal. Okay, we find the pattern. Okay, we're going to find the pattern. 1, 5, 12, 22, 35. 6, 4. 4, 7 and 13. So it will add up every 3. Plus 3, 16. This is 51. It's 19. Going to be 70. 21. Oh, 22. Keep going until you find the nth number. 1, 2, 3, 4, 5, 6, 7, 8. One more. So the answer is 117. For number 12, you can use algebra for this. Also, you can count it manually, but I think the faster is the algebra. So 1000 is 1001 is 1000 plus 1, right? And then you keep doing this. This is the form of algebra. A is the 1000 and B is the 1. Like this, right? So that means we expand. Well, you have to know algebra for this. And then we substitute everything. So this is 1000 to the power of 3. We do this. Okay. So this is 3 million. This one is 3000. This one is 1. Add up everything, you will get the question is the sum of the digits. You add everything, 1 plus 0 plus 0 plus 3. The answer is 8. Okay, for this one, this is the year. Yevgeny was born on August 24 something. He was in the 6th year of his 7th decade. So that means from the decade, 7 decade is start from 60 to 70. 6 year, we will do the counting, 60, 61, 62, 63, 64. Okay, this is the 6th year. So his age is 2015 minus 65. And then you will get, okay, this is the answer. But you have to find the sum of the digits. So the answer is 15. It has 3 pricing options: lift ticket, sky lesson, or both. Draw diagram, Venn diagram. This is lift ticket, this is sky lesson, this is both. On Sunday, 50 people bought exactly one of 3 options. 42 lift ticket and 23. If you add up, this is going to be 65, right? 42 plus 23 is 65, but you only have 50 people. So that means there are 15 people that both both 2 lessons. So this is 15 here, right? So the lift ticket, only lift ticket, right? So 42 minus 15, 27. And for the ski lesson, there are 23, right? 23 minus 15, 8. And then we count everything to find the average. So 60, right? For the lift ticket is 60. And then 15, 70. And then 8 people only skiing. So you count everything, 27, 15 times 7, this is 160, add up, right? So to find the average, you have to divide 2,830 divide by 50. The answer is 56.6. The nearest whole number going to be 57. So the answer is 57. Okay, find the whole number value of n. This is a algebra form. This is an algebra form, right? How do I know? Because there are two. There is 2 in the middle. So this is the A. This is the B. If you factorize, you will get this, right? So A plus B is 18. Find the whole number value of n. So that means the B. Find the whole number value of n, right? So A is 13. So B is 5. Okay, that's the answer. B is 5. The square of two consecutive whole numbers differ by 45. Find the lesser. You can go listing, or you can use algebra. The smaller one will be n, and because it's consecutive, the next one will be n plus 1. So because it said that the difference, right? So the larger one, this is the smaller, and the larger one is, because it's consecutive. So we use algebra for this. The squares, right? So the difference is 45. And then you just expand it like algebra. So this one gone. So n is 22. and it's 22. That's the answer. The lesser whole number is 22. Okay. For this one, 16 players enter a chess tournament which offer a prize to winner in each. We draw. There are 16 players. Winner of the matches in round 1 are placed in the upper section. The player who lose matches in round 1 are placed in the lower section. For the round 1, there will be no elimination. Okay, there will be no elimination. So, okay, we're going to make table. This is round 1. This is the players. Okay, this is the games. First, you have 16 players in round 1. 16, that means you need 8 games, right? Because you have to, well, you have to have opponent, right? So 8 games for 16 players. 16 divided by 2. You have 8 games. Because there's no elimination, the winner, you're going to have 8 winners and 8 losers, right? This is in the upper section, this is the lower section. And after this, there's going to be elimination. For this, in round 2, you're going to have 8 games. 4 games from the upper section and 4 games for the lower section. You're going to have 8 games in total. And then for the round 3, for the rest of the loser is going to be eliminated after round 2. So you will find 4 winners from the upper section and 4 winners from the lower section, right? Because the other 4 will be lost, okay? So for this one, you're going to have 2 games from here and 2 games from here. So you will get 4 games in total. And then after that, you're going to have 2 winners from here and two winners from here for the round 4, okay? And then you have 1 game from here, because there are only 2 people, 1 game from here. So you have 2 games. After this, you cannot have another game. In total, you will have 22 games. That's the answer, 22 games in total. Okay, for this one, a rectangular box is final shortest distance. Okay, for this, you have to flatten the faces, okay? This one, the front and the side. So imagine I flap this part to the front. I flap this and then move it to the front. And then you will get something like okay. If you move the side to the front, you flatten it. You open up the side and then you move it to the front, right? Then you will get this. And then we will write the side. Okay, this is B in the middle. B is the center, right? B is the center. So this is B. This is 7. This is 10. This is A. The shortest distance. Use Pythagoras. Use Pythagoras for this, right? So this is 5 because this is the center. This is 5 and this is 7. So in total, this is going to be 12. From here to here, it's going to be 12. It's going to be 12. From this, because this is the center, it's going to be 5. So AB, use Pythagoras, right? The answer is 13. This is the answer. Okay, for this one, suppose find the whole number of. You don't have to find what is Y, what is Z. You don't have to find that. If you can see, this is double, right? And then this one, if you double it and then you minus it, you will get Y. So I will write down, this is the first equation. We double it up. We double it by 2, and you will get I will write here for X, Z is 37. Then you eliminate. So from this one, you will get minus 5, minus 5, minus 6. So you will get 1. Z equals to, there, you have the answer. The answer is 17. Okay, for this, you have to list down, I guess. Find the least whole number value BCD so that blah, blah, blah. Okay, the key is this is positive, and also this is in the lowest term. Okay, this is in the lowest term. Okay, so first, find the greatest common multiple. Okay, so that means 6B plus 2C plus D need to be 17. You make table from this B, C, and D. Okay, I'm going to list down. If we put 1 in here and then we choose 1 also, that means 6 times 1, 6 plus 2, right? If we put 1, that means 6 plus 2 plus D. D will be 9. D will be 9. But we check, because this is need to be in the lowest term, we check if we put D is 9. So this part will be this. This is not the lowest term. You can still simplify this, so not this one. You keep doing this, 1, and then you try 2, and then the D you will get 2 times 2, right? You will get 7. This is all in the lowest term, so you adding up everything, you get 10, and then keep going. Try another one. 1. If you use 1, and then 3, 6, right? You will get 5. This is also not the lowest term because the C section, 3 times 2, 6. So this is not the lowest term. You cannot use this. 1, 3, 4, and then you can keep going. Keep going. Try 4. 17. 6 plus 8. D is 3. 3, if D is 3, 318. No? Okay, keep going. We try 1, 5, right? If we put 1, 5, this one. All of this is in the lowest term. So if you add everything, okay, let me erase this part. If you add everything, then you cannot, can it be 1, 6? 1 and 6, we try 17. 6 plus 6 times 2 is, it cannot, right? You cannot find D for this. So we move on to 1, 12, 1 times 2, it's 14, so D is 3. 3 cannot, because 3, 18. We try 2. So D is 1. Okay, BCD, for this part, BCD is 2 plus 2 plus 1 is 5. Can it be 3? 12 plus 3 times 2, 6. Okay, cannot. This one cannot. So this is final answer. Okay, because this is 10, this is 7, this is 5. This is the smallest one. So the least whole number is 5. The answer is 5. The answer is 5. For question 21, how many of the first 10,000 positive integers contain the digit pair 43 in that order? You have to list down. So for case number 1, 2-digit number. There are only 2-digit number, 1 possibility. And then for the 3-digit number, the possibility is like this, or like this. If this is the possibility, you cannot put 0 in front, right? Or else it's going to be 2-digit number, cannot put 0. So there are only 9 possibility. For this, you can put 0. There are 10 possibility. Move on to the third case, 4-digit number. You can go like this. You can go like this. You can go like this. For this, the first digit cannot 0. So there are 9 possibility. The second digit, you can have 10 possibility. So the total is 90 possibility. Same with this, right? The first digit only have 9 possibility, the last digit can 10. How about this one? The same. The same? No. The third digit can be 10. The fifth digit can be 10. The fourth digit can be 10. But as you can see, especially for the digit like this one already have in the first scenario in here, right? You can find 4343 here, and also you can find 4343 here. So you have to reduce 1 possibility, so it's 99. Adding up everything, 1 plus 9 plus 10, which is 20, right? And then you add 90 add more 90 and 99. So the answer is 299 integers. This is the final answer, 299. Each of 1000 ping pong balls is labeled with exactly one of the counting numbers. Each ball has a different number. If the ping pong balls are selected at random, what is the fewest number that must be selected? And set aside to be certain that the sum of the numbers on two of the selected ping pong balls will equal 1005. We use pigeonhole principle for this. If you haven't know the pigeonhole principle, you can Google it, okay? So the basic thing is you have to find the worst case scenario. We have to find what pair that possibility can make 1005. For example, for the number 1000, the pair will be 5. It makes 1005, right? For 999, going to be 6. This is the first group. Let's say this is the first group, and then this is the second group of the balls. And then you keep going to add up. Okay, so there are, if you notice that there are 4 numbers that cannot pairing with anything, which is because this is the smallest, it's 5. So the ball with the number 1, 2, 3, 4 have no pairs at all, right? So there are 4 numbers that cannot have pair. So imagine that you are going to have, if this continue, you're going to have, because there are 1000, and then we minus it with these 4 balls, and then you will get, so you will have 4,996 divided by 2, 488, no, 9. Okay, you're going to have 498 pairs. You have 498 in here, in the first group and in the second group. Imagine the worst case scenario is every time you take the ball, and then you're going to have all numbers that in this side. Each of these balls cannot have pairs, right? So we think the worst case scenario. The worst case scenario is every ball that you take is going to be in the same group, which cannot be paired. So, for example, you take 498 balls, and everything, the worst case scenario is all the 498 balls that you take came from the exact same group. That is the worst case scenario. Even if you take if you take the balls and then it contains 1, 2, 3, or 4, you still don't get the pairs. So this is 512, right? So that means once you take all worst case scenario ever, you take the wrong ball, and then the next one is going to be have pair. So adding 1, the answer is 513. Okay, so after this, then you will find there's no more option. This one, you will have, no matter what, you will have 1 from this group, at least. So this is the number, 513. This is called pigeonhole principle. Search it up, okay? Number 23. A square floor is completely covered with non-overlapping 1 times 1 white and 1 times 1 black. The tiles along the two longest diagonals are black, while the remaining tiles are white. So you have to draw to imagine this, okay? This is the floor. Imagine this is the floor. So there are 41 black tiles for the diagonals. So that means 41 divided by 2 is 20, remain 1. So this one, the remainder, must be in the middle. Must be in the middle. So 20 go here, the rest, and 20 go here. From each diagonal, there are going to be 21 tiles. Imagine that this is the diagonal, the black one. Okay, draw until up here. So there are 21. 21 go up here. So for each black, it's going to be 1 white, right? It's going to be 1 white, 1 white. So you will have 21 tiles here and 21 tiles here. So you can find the area of the floor. The area of the floor is 21 times 21, which is 441. Minus it with the black tiles to find the white tiles only. So this is only the white tiles. That's the answer. White tiles is 400. Okay, 24. The shaded region shown is the area which lies both inside right angle and outside resector arcs. Okay. Arcs radius 4, center at the 3 vertices. When the side of ABC is 9, 12, and 15. The longest will be 15, so this is the longest. This is 9, this is 12. Area of the shaded region. Okay, area of the shaded region will be the area of triangle minus the whatever, the semicircle, right? The total of the arcs. So the area of the triangle base is 12 times 9, 6, 54. This is the area of the triangle. Okay, for the 3 arcs, as you can see, the angles, if you put them all together, is 180 degrees. Because this is triangle, the sum of the angles are 180. So that means if you gather these 3 arcs, it's going to form a semicircle with the radius of 4. Right? So the area of the semicircle is 5 times 4 squared, you will get 8. The shaded region will be 54 minus 8 pi. This is the shaded region. So the P, this is the P, right? And then this is the Q. So P minus Q, 54 minus 8. That's the answer. The answer is 46. So now we're going to 25, the last number. Okay, the last number. Lattice point is a point with integer coordinates. That means cannot have decimal for the points. Straight line segment is drawn between points A and point B, including the endpoint. How many points on straight line segment? So you have to find the ratio for the x and y to find out if you move y to certain number, how much it will move the x. Okay, so for the y, this is the range of the y. So the ratio will be divided by 6. Every increase, every 4-point increase in y will be increased 5 point in x. So you make table, right? You make table, and then you count by one by one. Start from -6 until 24, and then this one is start from 5. Every increase x 5, yeah, going to be -1, and this one will increase 4 point. And keep going. X increase 5. This one going to increase 4. Increase 5. Or you can adding up until you find 24. Increase 5. Increase 5. Increase 5. There. This one will be increasing 4. Oh, yeah, increasing 4. There. So there are 1, 2, 3, 4, 5, 6, 7. 7 points. This is the answer. Okay, I hope that helped. If I'm teaching too fast, you can pause and then think. Or if you want to practice, you can pause my video, see the problem first, and try to figure out before you listen to the answer. Okay, good luck for your contest.